Hello everyone, today we are going to explore an application question involving differential equations. So a housewife places a piece of meat at a temperature of 35 degrees into the freezer. After T minutes, the temperature x degrees Celsius of the piece of meat satisfies this differential equation. So using the substitution y equals to dx over dt, we need to find x in terms of T. Also, the steady temperature of the meat when it's left in the fridge for a long time. And we also need to comment on the appropriateness of the model. Now, to get x in terms of t, the idea here is to solve the differential equation. And the very first thing we need to do is to differentiate the given substitution with respect to t. And the result is d squared x over dt squared. Which then brings us to the second step, which is to substitute these terms into the differential equation quickly. So as you can observe, the equation now has the variables y and t. Now let's move on to the next step, which is to separate the variables by bringing all the y's on one side and placing all the constants on the right, so that we can integrate both sides with respect to t immediately. Now integrating 1 over y gives us ln modulus y, while the right hand side is equals to minus 1 over 10 t plus c, where c is an arbitrary constant. Now let's try to make y the subject first, as we are mindful to work towards the end result, which is to express x in terms of y and t. Now to make our working more elegant and neat, simply separate the constant from this expression and replace it with a, where a represents plus minus e power c. Now this is not the final answer, as we need to replace y with dx over dt, which is a e to the power of minus 1/10 t. Following which, let's separate the variables here again and integrate both sides with respect to t, so that we can make x the subject. As this is quite a straightforward integration, x is equals to minus 10 a e to the power of minus 1 over 10 t plus d, where d is also an arbitrary constant to be found later on. Now we will then need to deduce the steady temperature, which makes use of this expression here, because x simply represents the temperature of the meat. Now what we can do first is to find the value of the constant d by substituting t equals to 0, x equals to 35 into this expression, because the temperature of the meat is 35 degrees at the start when the meat is placed into the refrigerator. Now doing so, we will have 35 is equals to minus 10 a e power 0 plus d, and we have this equation over here, 35 equals to d minus 10a. Let's try to label it as equation number 1 and try to find other information in the question to form a simultaneous equation. Now we see that when t is equals to 10 ln 2, x is equals to 15 over here. 15 is equals to minus 10 a e power minus 1 over 10 ln 2 plus d, and this will be equals to minus 10 a e to the power of minus ln 2 plus d. Following which, by simplifying further, 15 is equals to d minus 5a. So let's name this as equation number 2. Now by solving the equations 1 and 2 simultaneously, a is equals to minus 4, while d is equals to minus 5. Therefore, x is simply equals to 40 e power minus 1/10 t minus 5. Now let's move on to the next part, where we are going to deduce the steady temperature when the meat is placed in the fridge for a long time. Now you don't have to actually draw a graph, but to help you in your understanding, we can make reference to this graph of x over here to deduce the steady state. Now notice that as t approaches infinity, e power minus 1 over 10 t approaches 0, and therefore, if you can see over here, x approaches minus 5. Therefore, the steady temperature of the piece of meat is minus 5 degrees Celsius. Now to comment on the appropriateness of this model is appropriate since the ideal temperature for frozen meat can be a negative value, which is minus 5 degrees Celsius. Now I do hope you have learned something from this video. If you have any questions or comments, do leave them down in the comments box below, and thank you so much for watching.